All right, we're up to Unit 3, Lesson 17. Unit 3, Lesson 17, we're obviously we're skipping a few lessons here. We skipped lessons 14, 15, and 16. But Lesson 17 is actually a throwback to what we learned about when we did that Algebra 1 unit a couple of months ago, when we learned about the different methods of solving quadratics. Basically, we're going to talk about solving quadratics again. The only difference is this time the quadratics are actually going to have complex number solutions. So whereas in that Algebra 1 unit, we focused solely on quadratics that had real number solutions, these quadratics are going to have complex number solutions. So today, we're going to talk about that using the completing the square method that we learned about. And then the next lesson, we're going to do the same thing, except we're going to use the quadratic formula. But for today, we are focusing on completing the square. So step 1 for completing the square is to move the constant term to the right-hand side. So in that case, that's going to be this term right here in number 1. So to move plus 13 over, I'm going to minus 13 from both sides. So that gives me x squared plus 6x equals 0 minus 13, so negative 13. So that's step 1. Step 2, divide the coefficient of the x term by 2 and then square it. So the coefficient of the x term is the positive 6 right here. Coefficient of the x term. So divide the coefficient of the x term by 2. So 6 divided by 2 is 3. And then square it. 3 squared is 9. Step 3, add that number to both sides of the equal sign. So the left-hand side will look like x squared plus 6x plus 9. The right-hand side, remember, right-hand side we have negative 13. So if we add 9 to that, negative 13 plus 9 is going to be negative 4. All right, so on the left-hand side, x squared plus 6x plus 9. On the right-hand side, we have negative 13 plus 9. That's negative 4. Step 4, convert the left-hand side to factored form. So that's my add multiply. So what adds up to 6 and multiplies to 9? That's going to be 3 and 3. 3 plus 3 is 6. 3 times 3 is 9. So the factored form is x plus 3, x plus 3. And remember, x plus 3 times itself is really x plus 3 squared, right? Because x plus 3 times x plus 3 is x plus 3 times itself, and anything times itself means squared. Okay? And then step 5, solve the resulting equation by square rooting. So now I'm going to go ahead and I'm going to square root both sides of the equal sign. Okay, remember on the left-hand side, square root and squared cancel each other out, leaving me with x plus 3. The square root of negative 4, we should know, now that we've learned about imaginary numbers and complex numbers, we should know that we can treat the square root of negative 4 as if it were the square root of positive 4. So the square root of positive 4 would be the plus and minus positive and negative 2. The only difference is now we're going to tack on an I at the end. So the square root of negative 4 is positive and negative 2i. All right. And then to finish that off, we're simply going to subtract 3 from both sides. But here's the difference. Here's the difference. Because we have the I term, I can't do 2 minus 3 and negative 2 minus 3 because of the I that's here. So I'm just going to leave it as x equals plus and minus 2i minus 3. Okay? Now, when we talk about complex numbers, you might remember anytime we have a complex number, we always put the real number first and then the imaginary part, the I term second. So real number first, I term second. So when I actually write out my answer, I'm going to actually switch around the order. So look what I do here. I'm going to rewrite the answer like this. Okay, negative 3 plus and minus 2i. Is it the same thing? Yes. What did I do? I just changed around the order. So when you write your answer, your answer has to have your real number first, imaginary number second. So real number first, I, imaginary number second. Okay? So our answer here is negative 3 plus and minus 2i. Are there still two solutions? Yes. What are those two solutions? Negative 3 plus 2i and negative 3 minus 2i. And that is it for number 1. Let's take a look at number 2 now. So number 2, we're going to do the exact same thing. X squared minus 10x plus 50 equals 0. So step 1, move the constant term to the right-hand side. So I'm going to subtract 50. All right, change plus 50 to minus 50. So x squared minus 10x equals 0 minus 50. Okay. Divide the coefficient of the x term. So in this case, that's going to be a negative 10. Divide the coefficient of the x term by 2. Negative 10 divided by 2 is negative 5. And then square it. Well, in this case, we're squaring negative 5. Negative 5 squared, negative 5 times negative 5 is positive 25. Okay? So x squared, so negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. Okay? Step 3, add that number to both sides of the equal sign. So this will be x squared minus 10x plus 25 on the left-hand side. Okay. On the right-hand side, we have negative 50 plus 25. That's going to be negative 25. Okay. Step 4, convert the left-hand side to factored form. So that's my add multiply thing. So two numbers that add to negative 10 and multiply to positive 25. The only way I could have a negative sum and a positive product is to have both numbers be negative. So in this case, it's going to be negative 5s. X minus 5, x minus 5, right? Because negative 5 plus negative 5 is negative 10. Negative 5 times negative 5 is positive 25. Okay, so I converted the left-hand side to factored form. Now remember, x minus 5 times x minus 5 is really x minus 5 squared since it's being multiplied by itself. Okay, so solve the resulting equation by square rooting. So now I can go ahead and square root both sides of the equal sign. Once again, I'm going to end up with a complex number. So on the left-hand side, square root and squared cancel out. On the right-hand side, the square root of negative 25 is going to be positive and negative 5i. Okay, remember, treat it as if it were a positive, but then tack on an I at the end. And then I'm going to finish it off by adding 5 to both sides. And I end up with plus and minus positive and negative 5i plus 5. But if I rewrite it, like I said, rewrite it in the correct order, real number first, imaginary number second, it's going to be 5 plus and minus 5i. So once again, I still have two solutions, 5 plus 5i and 5 minus 5i. Your cool down today will be a couple of examples just like what I just did.